Okay, ladies and gentlemen, welcome to this opening section for the EuMIC 2022. My name is Paolo Colantonio, as you probably already know. I'm the chair of this event, and I wish to bring you, on myself, and on behalf of the team, our warmest welcome to this event. For the organization of this event, of course, there are a lot of people behind that contribute to the realization. So I would like to present you the core member for the organization, that are myself as a chair, my co-chair, Francesco Barletta, my TPC chair, Alessandro Cidronali, and the TPC co-chair, Rocco Gioffre. Where is? Okay. The program of this session. Today we will have two invited speakers that I wish to personally thanks for their participation, for their contribution. And we will have a third speaker, invited speaker, at the end of the event in the closing session. The first speaker will be Massimo Comparini, the CEO of Thales. The second speaker will be Sergio De Ceglie, again, a member of the city of Thales. And in the closing, we will have Nathaniel Ayon from the ESA, the European Space Agency in ESTEC. For the closing session, please remember that this year we are also organizing inside the closing section also the Foundry Panel. That is our traditional event in which we will invite some foundries, and here you will find the foundries that have accepted to join us in this event, where we have a discussion with this company to discover what is their technology idea, technology trends, and to share some comments with them. This session will be chaired by Mark Roquet and Andrea Suriani, that I would like to thank for their support in this activity. And last but not least, in the closing section, remember that we have also the award ceremony, in which we will provide the award and we prize the best conference paper, the EuMIC Microwave Prize. We will give also a EuMIC Young Engineer Prize to grant the young engineer that is cooperating, that is collaborating and producing papers, interesting papers in this event. And last but not least, we want to remember our friend of us, sorry. Okay, we want to remember a person that gave a big contribution to this event, our friend Tom Brazil, that passed 2 years ago. Okay, sorry. Last but not least, at the end of this day, that it will be a very busy day, in order to take some moment for relax, to exchange ideas, to have networking, all of you are invited to our traditional get-together event that will be organized in a location called the East End Studios. Here you can find the address. There will be a bus service organized starting from 7 p.m. with a bus from here to the MiCo and coming back at the end of the event. This event, and I would like to thank, is sponsored by the Gallium Arsenide Association and by the Thales Alenia Space. And please remember that you have to take a ticket in the registration desk in order to be admitted. It is free, but it is necessary to have a count of the number of people participating in this event for our national law related to the COVID restriction and so on. So it is mandatory to have the exact number of people. Okay, I will want to call my TPC chair to give you some figures for this event.
Thank you very much, Paolo. It's been really a pleasure to be in your team under your guidance. And welcome to everybody. I served as a TPC chair in these conferences, so it's my duty to give you some numbers about the submissions about these conferences. First of all, we are very glad to announce that up to date, this morning, we are 421 attendees, which is very interesting numbers, very nice figure. Also, with respect to the fact that we have just few months to organize this conference since the last one in London last April. The submitted paper was more than 104 for the precision, and just few of them were withdrawn. We reviewed about 100. Here there are some mistakes in the figure. So about 100 of paper were reviewed by the committee. The accepted paper has been 70 with 12 posters and 58 oral paper that will be given in all the sessions. So we got 67% of acceptance rate, which is about conventional number for this conference. We decided to include one invited industrial keynote in each technical sessions. This person comes from industries and academia, are very well recognized personality in their specific field. About the organization of these conferences, we have 17 sessions with a number of focus sessions. Precisely, we have 2 focus sessions, one on gallium nitride device modeling, and the other one is behind millimeter wave integrated technologies for wireless communication. As a tradition, we have also a joint session between this conference and, in general, the microwave conferences in the field of receivers and very high frequencies, terahertz communication system in the H band from circuit to system level. Okay, we have then poster session and joint poster session, as already said. Okay, this is the distribution of the submission paper per country. Again, this is not a news. We have a very big contribution from Germany, which seems to lead this field. Then we have, of course, a very interesting contribution from Italy, of course. We are here in Italy, so it was expected, this contribution from our committee, for our community. And then we have a very welcome contribution from US people, which contributed with more than 10 papers to these conferences. We had also other very significant contribution from France and Korea. Unfortunately, due to the contingent situation, we had not much contribution for the East, for the Far East. Okay, it is now the time to introduce our first keynote speaker. Most of them already knows him. Is Dr. Massimo Claudio Comparini, the CEO of Thales Alenia Space. I said he is the CEO of Thales and Deputy CEO at the Observation and Exploration Navigation Group at the Alenia Space. He was former CEO at the EGEOS joint venture between ASI and Telespazio. Also former CTO of Thales Alenia Space and former CTO of Telespazio. It is certainly a recognized personality in the community of the space engineering worldwide, and he was also the chair in several corsi di laurea at the university in Italy. he has about 40 years of experience in the field of space engineering. And so I would like to welcome on this stage Massimo Comparini for his talk.
Paolo, la presentazione è caricata qui. Se non viene a schermo intero.
Non va a schermo intero.
Thank you, Alessandro, and good morning to everyone. It's a really pleasure to be here. And I always remember yesterday night with Professor Giannini that my first paper was GAAS, gallium arsenide, GAAS NCO, numerical control oscillator, and it was in '92, the first of the second gallium arsenide symposium, which is today part of this very interesting conference. So what I will try to do in my keynote, it's the connection between a domain, which is the space domain, and the technologies. Space is a domain that, for all of us, for sure for me, has been of inspiration. And in this first slide, I put a few iconic images. The first one, which is the first footprint on the moon. By the way, we are back to the moon really in the coming days. Really, we are really anxious of the launch of the SLS Artemis 1, the LAM, which is the module, and Saturn V. So space has been always regarded as a highly strategic activity behind the industrial dimension, tightly connected with the technologies, and really an example also of the power of the two, at that time, big players, USA and USSR. In the coming decades, after the Apollo race, by the way, the new back to the moon will be named Artemis race, wife of Apollo, because NASA really want that in the new mission, we will have a woman as the first astronaut to come back to the moon. In the following decades, space has been an activity very important for a number of countries, and of course Europe, first of all. And also those three images are a little bit iconic, because the first one on the left is a comet, and the European Space Agency bring the hardware. The mission is Rosetta mission. The name of the comet, it's a bit complex to pronounce. But for the first time ever, our technologies allow to have a piece of hardware electronics, functioning hardware electronics, landing a comet, which is not really a kind of safe journey. In the middle, we have a picture of the Chinese space station, and on the right, we have the control center room of ISRO, which is the Indian Space Agency. Just to say that how, from the Apollo time to today, space is really very important for a number of countries, and Europe, with the constitution of the first bodies, institution that now, ESDRO and ELDO, now European Space Agency, for sure has been, since the 70s, a big a big player in space. So, through missions, quite challenging mission, you have in the center a picture of the Cassini-Huygens, again a joint mission between the NASA and the Italian and the European Space Agency, by the way, with a large contribution from Italy, a mission that went 9 astronomical units far away to study Saturn system, and Huygens, the ESA part, was conceived like a kind of flying disc that approached and really landed on Titan. Okay, the scientists want to take a look at this far away world because the atmosphere of Titan seems very similar to what was the atmosphere of the Earth really a billion years ago. So also through this really challenging mission, space contribute to think and to define technologies really at the state of the art. But in the last 15 years, we had a bit of change. Space technologies start to be really fundamental for our daily life, for our connectivity, the capability to observe the Earth from space, which is extremely important, just to give an example, for the sustainability of this planet, to manage what happened, to understand what happened. And so technologies and architectures change a little bit the paradigm, not only very important and breakthrough scientific missions, but also space infrastructure for our life, for our economy, for our urban communities, and for our life, which is extremely important also for the purpose of a conference like this, because that's a change. That's a change in the attitude that we should conceive and mature technologies to be able to be included in new mission. And so I'm sure that you heard the name, a so-called new space or new space industry emerge, which is based on a kind of faster life cycle, the capability to inject more rapidly innovation in our space systems, and new architectures, not only single big satellite, but also constellation and even mega constellations. And of course, we have really deep implications in terms of how to use the technologies and which kind of technologies, how we can change the paradigm, for instance, of a 99.9% reliability of a device. Because if we have hundreds of satellites, maybe it could be more convenient to have less reliability on the single node, but to have a systemic reliability to deliver the performance. And another change, which is really important, for years and years, we work on a technology push mode. So our goal, or my goal in the lab some years ago, as Alessandro remember, if I had a low noise amplifier, 1.2 dB, the goal was to achieve at every price 1.1 dB. So really technology push, performance-driven space. Of course, every performance has a cost, and the evolution of the space paradigm today, for some of the space missions, you need to design the right technologies at the right time at the right price. So we move also to a kind of user-driven or market-driven space, design infrastructure for the services that they are supposed to deliver to the government, the public administration, the community, to us. And today, it's really space is not only, let's say, a domain for a fantastic and inspirational scientific mission, but is really a domain essential, as I said, for our life. So definitely a space economy emerge, and we have, let's say, a number of calls, a number of newspapers, also, let's say, really much more popular than in the past, talking about those technologies. And I will go through a little bit on those elements to make more understandable the connection with the technologies of this evolution. So, what happened in that access to space, of course, is very important. So in the last 30 years, we see a lower cost in going to space. On the other hand, we had the possibility to design a variety of different sensors. I mean, if today we are capable to observe the Earth from space, we have radar sensors, we have optical sensors, we have multispectral or hyperspectral sensors. So the variety of the different sensors that we were able to put in space is really important to generate a huge amount of data useful for what I said before. So basically, two concepts emerge: global connectivity and global geospatial analysis. So the possibility to be connected every place, every time, of course, with a terrestrial network. But today we cannot imagine a next generation, a 6G network without a full integration of satellite capacity, and at the same time, the capability to observe with a much more frequent than in the past, even on the daily basis, and look into the future system, even on hourly basis, our Earth from space. Of course, let's say, linked to that, we have use of higher frequencies. So we move, and I will give you an example, from C-band, Ku, Ka, to V-band for the global communication, or LCX for our radar systems and looking to Ku and Ka, of course, with the different features that the bandwidth gives for a radar observation. But it's extremely important how the speed and the high speed was also the digital devices. So today, all our space systems are much more digital than even 10 years ago, and also software-based or software-defined, which is really connected also to a conference like EuMIC, in general, the European Micro Week. Because, of course, if we have a digital device which is running at gigabit, we have a signal at gigahertz that are passing through our boards. And if you face the challenge of a design like that in just pure digital or 1 and 0, it doesn't work. So there is much more very high-speed techniques in all those digital worlds that in the past. So constellations is really one of the buzzwords, the keywords of this evolution in space. And just to give you an idea, the demand of new satellite in the coming 10 years, 70% will be based on new constellations. Now, of course, if our satellite have a broadband, so we have huge amount of data passing through, this is part of the increased capabilities of our space systems. We need to communicate between and among the satellites. So we don't have anymore a single satellite, but we have nodes of a network that communicate each other. And of course, as easily you may understand, means that we need to conceive micro ISL or even optical and laser ISL. So again, we can imagine an architecture because we have the technologies to do that, and we need to study new technologies to enable new architecture, which is something that I will spend a few words also later on. If today we can conceive, constellation, mega constellation, different orbital planes, but even different configuration like cluster of satellite or swarms of satellite, because our enabling technologies today are able to do that. If not, it would be a kind of, let's say, theoretical architecture that we cannot find a way to make and to deploy actually in space. So I think it's important that we connect those three layers, the architectures, the single node, so a satellite, or let's say the main subsystems of a satellite, an antenna, a phase array, a digital processor, a converter, all those pieces, and then the enabling technologies. Also because cost is for sure a driver for the majority of those applications. And in order to reduce the cost, no way. You must reduce the parts, the number of parts, you must reduce the testing, and you must be able to do that in a much more automatic way when we're building our satellites. So, of course, if we have something which is flying around the Earth or very far in the solar systems, we need to have a ground system that are able to keep the communication back and forward to the satellite or the constellation. And then we need to have from the ground infrastructure the way to make available the data. So this evolution in the space systems is not just isolated in how we build the satellites. We will have trend in the so-called upstream, the space segment. The digitalization of the space segment is such that compared to the past, we have much more dynamic interaction between space and ground. Our ground systems that control those complex architectures. And last but not least, digital technologies, cloud, and even AI are fundamental to exploit all the data, or to use at the best the capacity that we put in those systems. So I give just a few highlights of what are the big building blocks that move forward in the last 10, 50 years. Of course, microwave, millimeter wave communication, radar, and payloads. So today, we have Ka band, D band, so the move forward in the frequency. Optical and laser communication is extremely important to make possible, for instance, deep space communication, as well as to have, let's say, the satellite talking each other in a complex constellation. Ultra-high-speed digital processing and onboard power computing. Ultra-high-density payload, and this has opened the way to something that has been always very important, but it is today, which is how to have the best thermal design, having in mind this incredible integration of electronics. So how to spread the heat, it's becoming important, as well as our capability to design advanced devices or microcircuit. Last but not least, already mentioned, software-defined payloads. And then we have the lower technologies. So all our radio frequency and microwave devices, of course, the platforms to make possible to integrate tens of millions of gates in a single chip. So today in space, we are using platform at 28 nano, but we are looking also to lower scale. Active phase array, and you know that I give you a few examples, but an active phase array today, both for telecom and radar, may have thousands of TR modules. And of course, the integration level that we need to have today is completely different even a few years ago. Large deployable antenna systems, and advanced system-on-chip and packaging technologies. So I think that we are starting to, let's say, to have a view of the spread of the enabling technologies that we need to conceive the new architecture in space. And I give just a few highlights on those two domains, the global connectivity and global geospatial. I mean, the demand for even faster broadband internet connection and communication basically is making, let's say, two class of architecture for the telecom satellite. The so-called very high throughput or even ultra throughput satellite. I'm talking about 6 or 7 tons of hardware giving 500 giga, if not tera plus on a single satellite, with the capability just in less than 10 years to multiply more than 10 that. And low and medium orbit constellation, so low latencies, global communication. Latency, of course, if you are 36,000 kilometers, you have a certain latency. If you have a global constellation orbit at 400 kilometers, so you have a latency of few 10 milliseconds. Of course, latency and low latency is not only the plus of the mega constellation, but is also their capability to have a global coverage. So those are the two system architectures that today we have in place. Okay. And I give you an example, a satellite that we launched just 3 weeks ago. I'm sure that you know Eutelsat, which is one of the operators in Europe. So this is a 6 tons plus satellite. Imagine a bus of 9 meters and the wing of 45 meters. So this is the kind of class of satellite that I'm talking about. A satellite that is able to deliver more than 500 gigabit per second. And just to give you an idea, that has been launched 2 weeks ago, so September 2022, compared to its broader launch 2 years ago, the overall capacity has been multiplied by 7. So 2 satellites, same class, launched just 2 years distance, the capacity has been multiplied by 7. And of course, you can imagine Ka band, multi-beam, and all of that digital process. Then we have the constellation, where of course the capacity is not the capacity of the single node, but it's the capacity of the entire constellation. And we have a number, I'm sure that you heard about Starlink from Elon Musk, Kuiper from Amazon. So in this case, what we have today, it's more or less a capacity between 10 tera on a single constellation. So it means that today the target, you see 2023, be 2025, but Starlink is already in operation, is to have a system that just 2 or 3 of those systems will give a global capacity of 25, if not 30 tera in space. And of course, you imagine that if you are able to deploy those kind of space infrastructure, the cost per bit is comparable to what we have on ground. And so it means that we will be connected in every place, every time, regardless, we don't care. We don't care. We'll be connected through satellite. If we are in a remote area, we will connect to a 6G network and so on. A number of those constellations. I mentioned Starlink. We are engaged with Telesat, a constellation of 298 satellites, OneWeb. And this is just give you an idea of the kind of, you see on the right, 10 terabit per second global capacity just for the Telesat constellation that we conceive, Ka band communication, optical inter-satellite link, on the orbit intra and intra-orbital planes and across the different orbital planes, and of course, all digital processing. But global connectivity is not just a paradigm. We need to have more and more secure connectivity. And so here we open a kind of let's say, really interesting topic, which is the quantum communication and quantum key distribution. And that's an example of technologies that still few years ago were at a very low TRL in the research lab, and today we target to go with the first space system based on quantum in 25, 26. So really there is a kind of acceleration of this process. I'm sorry, there is two pictures here in the wrong place. But anyhow, just an example, for instance, we are working with the European Space Agency on a so-called SAGA project, security and cryptographic, which will be one of the elements to give the secure connectivity to one of the projects that Europe, very similar to what has been done for Copernicus and Galileo, is pushing, which is European secure constellation. Because we know that we cannot rely also for security reasons just on the commercial infrastructure. So let's spend a few words on the Earth observation. I just mentioned Copernicus is the most important program in the world for the Earth observation. It's a flagship of the Commission. We started more or less with the first studies 15 years ago. First satellites has been launched early the last decade, to 2014, Sentinel-1. And it's very important that we understand that to observe the Earth from space is essential for two things. One, if we know what happened on the Earth, we can understand how make the planet sustainable. And the capability that through space sensors we have to observe the Earth is fundamental. We cannot build a sustainable planet without space technologies. We cannot have the tomorrow agriculture and also the today agriculture without satellites. So the Commission and the European Space Agency managed to deploy the first phase of Copernicus. There are today 6 different types of sentinels, and we are working at the data generated by those satellites are essential for land monitoring, emergency management, climate change, security, marine and atmosphere monitoring. And now we are entering a new phase. We are adding 6 new missions, so new radars, new radiometers, new altimeter, basically to have a digital twin of the Earth. Through those data and through much more frequent revisit, so the capability to observe again the same place in the Earth, not after many days, but maybe after 6 hours, is essential to generate a digital twin of the Earth. There is a part of the program which is called DTE, Digital Twin Earth. And again, that's essential to understand, and that's essential to manage the remedies. And you cannot have any single of those sensors without microwave devices, without the small things that we debate also in a conference like that, our MMIC or our, let's say, we cannot. Radiometers, up to 300 gigahertz. Radars, up to Ka band. Altimeters. All of that is built with the technologies that we debate since many years at the European MiCo Week and also at the GAAS Symposium and European Micro-Integrated Circuit. So just to give you an idea, Copernicus Sentinel-1, 2 satellites in orbit since 2014. Next one will be launched 23 and then 24, a total of 4. C-band digital radar payload, C-band active phase array, very high-speed ground communication link. Higher the resolution of the image that you acquire, of course, more the speed that you need to download the data to Earth. Roselle, L-band digital radar, L-band active phase array, very high-speed communication link. Of course, the combination of L-band, C-band, and X-band radar observation is essential because you basically have different acquisitions of course, in line with the penetration and the different performance that the radar at different bandwidths. CIMS, Copernicus Imaging Microradiometer. I'm sorry, this is a chart in Italian. Imagine the performance that we can have in a bench of different microradiometers with a huge deployed reflector that is, you see here, sketch in the picture. This is going to be launched in 2027 and 2028, 2 satellites. That's an example I will show you of quite powerful radar, deep submetric, based not a full phase array, but on a deployable reflector and active feed array to have, in any case, the flexibility of E-scan. Okay, I just mentioned a few of our solution radar. I don't spend time on that. It's not a company presentation, but I cannot skip, let's say, to give a flash of one of the most advanced radar, space radar that has been never conceived. This is a picture of the Cosmo second generation. So Cosmo is a constellation of 4 synthetic aperture radar, 2-ton plus, conceived for the Italian Space Agency and Italian MOD. Each of the phase array antenna has more than 5,000 active modules. And I still remember, Shmuel, I was at the Ilan Ramon conference in 19, and we launched the first satellite a few days before. So everyone was really interested to understand, hey, how is working this radar? And I said, okay, it's working like a machine, 2-ton plus, 20 kilowatts of impulse power. And I say that because it's important that we understand that, for instance, when we discuss about small sat, we need to understand that physics is physics, and to have a certain resolution, you need power. Typically, power means weight, and for sometimes when you listen in some conference with CubeSat, you can do wonderful things that are just cheaper and faster than big sat. Okay, let's understand a little bit better what they are talking about. And just to give you a snapshot of what is going to happen in space, in the picture on the right, you will see the deployment of new systems, mainly constellations, but it's impressive because in the coming 10 years, we will have quite an exponential growth of new systems to observe the Earth, and for sure that will generate a huge amount of data. Okay, navigation, we don't have time. Just a snapshot. Space economy is also entering the exploration phase. We think that exploration was okay, just to understand what is the chemical compounds of the regolite on the moon. Today, in the low Earth orbit, we have an economy which is raising up. We start to build the first ever commercial space station, so a station that has been built not by agency, but private funds, because we are going to have in space activities like new materials, research from 3D printing, organic 3D printing, made in space, and so on. I mentioned that because, of course, in order to sustain all of that, as you can imagine, we need to have continuous communication systems. We need to have IT and digital technologies able to give us how these complex machines are working. So basically, communications and sensing are essential. And if we need to equip all those large infrastructure where we will live, the astronauts will live, of course, we need the technologies and the devices that we know quite well. Okay, I will not spend some time also if I know this is quite always fascinating, like the picture on the bottom, because if, let's say, in looking to the end of this decade, and between 2030 and 2035, we will start to have the first, let's say, lunar foundation habitat, so I mean the first stable capability to stay on the moon, we will need also around the planet, very similar to what happened around the Earth, communication and navigation. We need to know where we are, and we need to communicate. And that's the reason why NASA and ESA has a project which is called Moonlight, where we are working on already in the infrastructure, and my old friends of Telespazio, they are working on the service side, because in the coming years we will have service connectivity to make possible the connection in every place you are, not on the moon, but on the south pole of the moon, because the south pole of the moon is the place on the planet that we are going to populate in the coming decade. So, just to give a final, let's say, connection between the technologies, of course, to make possible all of that, we need radio frequency and microwave payload. We need devices and system working L band and C band, X band, KU, KA, V. I see Mark here that, of course, we work a lot on. You know, you need a lot of core chips. You need a lot of HPA, LNA to make a TR module much more integrated than was just a few years ago. And that I give just an example. Today, if, let's say, just to give you an idea, if 15 years ago we had TR module built up with 10 chips, if 7 years ago we had a TR module built on 4 chips, now we have just 2 chips. Just a chip which is integrate the GAN LNA and GAN HPA and a core chip, just to control phase and amplitude of each module. And in an antenna like that, you have more than 5,000 of those modules. So imagine the complexity and what is also the challenge to have that at lower cost, generation by generation. But, and I hope that, okay, this is a small video because I think it's really, I found myself really interesting. This is an antenna that we build for a constellation that we are building for CARI, so the Korean Space Agency. It's a 6 meter diameter. You see on the top you have the active modules, 250 if I remember well. So we combine the E-scan of an active feed with the, let's say, I don't want to say the lower cost, but the fact that you can have a submetric resolution using a reflector like that, deployable in space with a radar which is about 1 ton. Of course, let's say, imagine all the complexity of the material and the mechanism to make possible something like that. So, just to finish, of course, I started from constellation, mega constellation architecture, just to land at the end our devices and our chips. And again, without evolution of those technologies, you cannot imagine the architecture, and vice versa. So I think that this is a message also for a scientific community and industrial community, which is typically in this conference, because, okay, Alessandro told, I mean, I was a CTO for many years, and I found really interesting that the most important challenge and contribution that a technical guy could give is, okay, imagine and prepare the technologies that some system and architecture engineer will ask you. Because typically, and it's a return of experience of a big company, it's difficult to have, let's say, this knowledge spread in a way that you have a communication link between the architects and the technologists. And sometimes I realize that if you have a system inside the industry that is able to connect, how is important to have the right technologies and to push for the right technology at the right time, you can also conceive amazing architecture. So we don't have more time, but you can imagine how the level of investment to make possible things like that, and which is today, of course, is also very important, the additive manufacturing, the plastic molding, and all what is around and is used to encapsulate our devices. So just to conclude, the space industry is really it's a domain that really fast move in the last few years. We move from the Apollo time, where it was just simply the way to show the power of a political system and the superpower at that time, to something that is essential for our life, for our economies, and for the sustainability of the planet. In the last 10 years, there was quite an impressive acceleration of new class of satellites, new principle, new constellation, new sensors, and all of that enable new services. And that is really the mechanism that generates the space economy. To give you an idea, today the space economy, it's on the yearly basis, so on 1 year is about 400 billion euros, and estimation give us a kind of trend to be 1 trillion industry by the end of the decade, which is, by the way, not far from the semiconductor industry, which is more or less worldwide, not far from the 1 trillion. So the last message, and of course, is a message, if I allow me, from a technology guy, not from the CEO of a company. But without those technologies, all what I show cannot be possible. And so I think that is extremely important to understand and to find a way from the scientific and the academic communities to make able that this evolution of technologies continues, and continue also the generation of the competences, because we are in a quite critical phase where the competences are, of course, always, but the competences will be a clear bottleneck. Let's say we need a huge spread of competences and also a number of people that are able to design technologies for those kind of systems. And this is extremely important and is debated at European level, because if we want to keep a leading role for Europe and each of the member states, but for Europe, we need also to think about a kind of sovereignty in the generation of the competences. Thank you.
Thank you very much for this very interesting overview about technologies. I believe that from audience there will be some request of more comments. Please, you have the chance to take the opportunity to talk with one of the most representative person in the field of space engineering. So if you want, you can address some question to him. Don't be scared about this. Okay. No, okay. I just have a curiosity about, I'm also involved in vehicular technologies, and you mentioned that with mega constellation, we have the promise of low latencies communication. Can you ensure that also vehicular technology can take benefit from communications, and in which kind of?
Today, the automotive and vehicular communication is one of the elements where those mega constellations find the market to be deployed, absolutely. And of course, as you can imagine, there is quite a complex mechanism in terms to make, let's say, okay, the connection. You will move from one satellite to another, from a station to another, it's completely seamless for you, but this in terms of architecture of the system is extremely important, and I refer more than one time how digital processing is essential. How is essential the integration between the terrestrial and the satellite network. So 6G will be the combination of all of that. Vehicular domain, let's say communication is essential for the market of those constellations, absolutely. And I think you know. That's the reason why we are working also, the space industry is working with the automotive industry to understand what will be the requirements. And I remember also some years ago, I was at the research center of Fiat, now Stellantis, and they were imagining the car in 20 years ahead like a kind of communication node with the 4 wheels, but a communication node, like a 6th generation airplanes. It's not anymore an airplanes, it's sensors flying.
On the ground rather than on the air. Okay, if you have some other curiosity or you want to take the occasion to talk with him. Yes, please, the microphone.
Yeah, in your slides, you showed large deployable reflectors at different frequencies, and then also you showed the phase array technology for L-band also. My question is, can you comment on which of the two technologies is likely to be more adaptable, or is it a marriage between the two that is going to
okay, it's difficult just to give a simple answer, and I show both examples because at this stage we need both of them. But you know, it's clear that in terms of reconfigurability, both in telecom and rather an active phase array will give a feature that you cannot have, or you may not have so simple with a reflector-based antenna. But again, there are so many different requirements and different applications that I think for many years we will stay both with reflector-based systems and big antenna farms and phase array. It's a fact that in the last 10 or 15 years, phase array technology had a kind of amazing progress, and today we use much more than in the past. But this is again coming from the integration that we were able to have through devices. I mean, again, today we have the TR module, and so transmitting receiver that are just based on a single chip that was not possible 10 years ago. So I think that phase array would be for sure a kind of breakthrough evolution that we'll have still in the coming years.
Okay,
thank you.
Thank you very much. Okay, I believe that at this time, Massimo, the organization has some present for you, I believe. Which recognize many of your efforts.
Yes, we are pleasured to give you this book with the symbol that we are using also as our logo in order to make a record for this event.
Thanks. Thank you, Alexander. Thank you. Please also remember that he's one of my shareholders, Leonardo, so just keep in mind.
Okay, so dear colleague, now is the turn of our second invited speaker. His name is Sergio Ugo De Ceglie. Ugo is presently a CTO and head of technologies at Thales Alenia Space. He was formerly the captain engineering of the Italian Navy. He has retired a few months ago and now works as a head of technology at Alenia in the field of strategic perspective of technologies for defense. He was also the responsible of technologies innovation for the Ministry of Defense. So thanks a lot to be here today, and please, the stage is yours.
L'ho spento. Sì, per ora sì. Oh. So, good morning, and thank you for the invitation. Can you hear me now? So, let's try it. Okay. So I choose, and I thank the organization, and I choose a tricky topic to speak about. It's the strategic perspective of technology in defense. Since I just left defense, so after serving for 28 years, and so I've seen the evolution of what's happening in technology. At present, our conception of the battlefield is based on land forces, Navy, Air Force, and then the new domains which are space and cyber. But technology is very much changing this framework. Why? Because NATO in 2015, as far as I remember, made a new concept of the multi-domain situation and the new battlefield. And so an example is given in the right figure you have, in which a project from the Massachusetts Institute of Technology, named TARF, gives us the perception of the information flux between different domains. So we have radar and underwater, which would have been inconceivable just a few years before. In this case, they studied how to change information from an acoustic situation to radar. So there is just a limitation. That means that a submarine can't receive at present information, but hopefully they will in the next future. So, which is the evolution? How are we? Which is the path we are facing? We have an hybrid threat, and I don't think that there's the need to speak about this. I'm not using this. So, we have new technologies which are becoming very much important in the years. And then we have two new domains, space and cyber, which are very important. So, because they deal with information, communication. Maybe I can learn from Massimo the term of global connectivity. And so what is changing in the framework is exactly the need of information. Decision makers need a very fast flux of information in order to take decisions which are effective and very chirurgical. So, where are we going? We are in a situation of a conflict model in which our idea of conflict is that we have bloody situation. We are moving towards a resilient model. We are moving towards a deterrence model which is based on information, based on deterrence, based on nurture conflict immunity. So avoid violence by gaining the information superiority. So at present, we have this. We have armed forces, each of which is having its own data and sharing somehow data with other armed forces and also in international environment. Now we are going in that new paradigm, which is a capability-centric approach. Our idea is to have the chance to share information coming from the three main domains that at first I told you about, which are land, Navy, and Air Force. But we have to add cyber and space. So the actual decision makers take decisions on the OODA loop, and they decide by gaining information from the human landscape, maybe human activity, by taking information from physical landscape, maybe Earth observation from space, Earth observation from airplanes, situational awareness in general, and also information landscape, which covers part of Earth observation and part of cyber. So, which are the main directions which are being taken by the defense? I am not just talking about Italian context. I've worked several times in EDA context and in NATO, so this is an idea which is very deeply shared among countries. We have the two new domains which have to be integrated, and then we have technology. Technology which has to take us to unmanned vehicles, and the main reason for which we have to pursue the unmanned capability is that we can save lives. Because if we have unmanned vehicles, autonomous vehicles, at the level of autonomy that it will be the man who sets, which is that level, then we will save life. We will have safer soldiers, we will have safer populations. And so, the drivers for technology developments are the ones enlisted in this slide. So, we need connectivity. So, the capability to exchange, we will need space. Massimo just told us a lot of very interesting things about connectivity. Autonomy. In autonomy, I will not deal with ethical issues because it's not my field. But we have to think that autonomy has to be, needs a governance. We need someone to tell us how much we want system to be autonomous. Then I will speak about sustainability, and then I will go to the more tricky word. Sustainability. It means that we have to encourage additive industry, we encourage supply chain, so everything should go with the technology towards this kind of situation. And now what can seem to be tricky, lethality. What I intend with the lethality is not the capability to kill people, but to have the capacity to be so precise, so accurate, to reduce at very close to zero, because statistics is over us, to reduce every kind of collateral damage, so that no civilian has to die in a conflict, or that civilian environment has to be preserved, and every kind of conflict with violence should be, first of all, lowered by using information. And then what is the less has to be very much chirurgical. For example, I'm thinking to laser gun. Is it possible to say this, this word? Laser gun is very chirurgical. We have a spot of 1 to 2 coin, 2 euro coins, so it is very precise, and we don't have all the problems of future point calculation. So which are the main enabling technologies that we should pursue? Quantum, artificial intelligence, cybersecurity, and in-orbit services. I'm not going to speak deeply about single technology, but I just want to give some pills, some idea of what the future can be. Massimo already said about QKD, so secure communication. QKD is already used for bank transactions, so it's very important. And also sensing, Earth observation, position, navigation, and time are very, very important, because by using quantum, then you can avoid all, for example, GPS spoofing. So, and for you, the technology ownership would be a very great enabler from all the point of views, from a market point of view, from a strategic point of view. And then this is a picture which gives us an idea of how we can use quantum. I was surprised when I found this. It's taken from the internet. And I was surprised because there are some applications that I hadn't in my mind. And I've been studying, because I proposed to study quantum a lot of years ago to the Italian Ministry of Defense. Quantum radars, we made some experiments some year ago with quantum radar. Chemical detections, underground mapping, quantum internet. Now some people are speaking about post-quantum cryptography. We should, first of all, gain quantum cryptography, I think. So, I pushed the wrong button. Artificial intelligence. Just a joke. Application, whatever you can imagine. Because it's a matter of what we want to think that the machine makes for us. So we can decide to have a man in the loop, or we can decide not to have a man in the loop. We can decide to have a supervisor. This is, going back to what I said, a matter of ethics, not techniques. So, for example, how can an asset, a generic asset, can move itself? In which kind? In which way? It's got a world model, which is a lab model. And then by use sensing as computer vision, GPS, LIDAR, radar, infrared, it will go in a loop of optimization of the context in order to be able to take a decision. And then it will have a feedback and go back to new. Maybe, I'm not a specialist, but maybe this is why we have a lot of UAV, because the air is very easy as an environment, so it's almost easy to model. Maybe a urban environment can be more tricky and more difficult. So the difference between human and unmanned vehicles is exactly how they work. A human born, usually, with skills, learn rules, then he gets his knowledge, and he's got expertise, because he's able to do things. Machines know how to do things, basing themselves on models. And then, just by training, they go back on the same route to skills. So imagine a defense context. We have started from traditionally manned ships and aircraft. Now we are having UAVs landing on aircraft carriers, and maybe they are somehow acted by from the aircraft carrier. Now we are more or less, I have a pointer, I think, more or less in operation centers. So we have some kind of autonomy, but we have not yet given all that autonomy. We don't have yet that kind of confidence. There are actions running all around the world about this, because save lives, because we don't have to forget that the topic is that unmanned assets are needed to save lives, to preserve human lives. And then we will have a context in which men and machines will work together at the same level, until, always waiting for a governance, if there will be, USV acting autonomously. Okay, I'm close. So, cybersecurity. Cybersecurity is very useful, as you can imagine, for secure communications via satellite, and for a lot of keywords that each of us has already heard a lot of times. And it is strategic for an EU defense. So, the public perception, when we speak about machines, when my PC doesn't work, maybe because it is Windows acted, or maybe because it is iOS acted, but we are always hungry to the machine. Firms are solving problems, are working on technology, and technology is very close to the edge. The very key actor in cybersecurity is always the man. So, in orbit services, here there are some applications. Debris removal, we will have to take a decision about debris removal. We can't go on thinking about. In orbit operations, real-time information from space. This is very important. Having a very good intersatellite link will help the battlefield, will help decision makers, will help autonomous system to take decisions. This is very, very important. So, unmanned vehicles need a balance, and give balance to the battlefield, because they ensure connectivity. They can be scaled vertically. You can increase, you can decrease the number of them, and you can accomplish different missions. You can integrate forces, human forces, and maybe they are based on the technologies that I show you. So, I don't think I will talk about this because we have few time, but maybe I will give it to the organization. So, why unmanned vehicles are so important? I will read this because they are free warfighter for critical operations because you have autonomy. So there is a decreased risk for human life, also to access difficult environments. They can operate so in complex situations and enable faster, scalable, and distributed decision-making, putting humans at the apex of the command. They give awareness and increase resilience. So, unmanned in all the domains that we have talked about are really a disruptive technology, asset which integrates all the technologies and many others we have talked about. So just the last 2 slides, which is the roadmap. We need the deep use of artificial intelligence, and we need to understand how we want to use artificial intelligence. Modularity and reconfigurability. Assets have to be integrated. Then we will have to ensure resilience, autonomy, and persistence. What is persistence? Persistence is the capacity of an asset to monitor a place for a long time, which is a mission that man can't do. Then we have to miniaturize payload. The more little they are, the better it is, because their energy consumption will be lower. And then we have also to study energy storage. And so, last but not least, the evolution is strong. We are going to a different framework. We are running towards different situation. Information technology is changing very much things. But human will continue to be the center of the decision-making process. The emerging and disruptive technology are transforming and innovating many sectors. And it is needed to make a cross-fertilization between civilian and military environment. And so technology has led to a significant evolution to the role of man in the dynamics of military confrontation. We have a problem which is all around the world. Few people are conscript. Everywhere I read on the article that this is a problem in the US, it is a problem in Italy, it is a problem almost all around the world, because information technology has changed our approach, our idea. So we have few people, and so we need quality people. Quality people able to be decisions, to give decisions. And hopefully, and this is my wish, is that next conflicts won't be bloody, and hoping that the one which is running will end as soon as possible. And will be based on communications, fast flux of information, and high technology.
Sergio. Thank you very much, Sergio Hugo, for this visionary presentation. If you have some curiosity if there are some curiosity from the audience, because I have mine. So, okay, please go ahead. The microphone is coming, yeah.
So thank you for a very interesting talk and a nice overview of the different technologies in all the different domains. So I think if we look at what you're talking about, we see applications for what we work on, microwaves and semiconductors, in lots and lots of places, which is great. I'm wondering where you think we need to work the most on. What innovations do you need from our technologies to help get to this vision?
Well, thank you for the question.
$1 billion question.
Well, I made, in my introduction, I said I will speak about what is most important. So it's like asking who you love more between your father and your mother. But I think, and maybe my slides my presentation gave this feeling, is that artificial intelligence and quantum are very strong key enablers which have to run in the very next future. The rest of what I said is something that you can also, and space, digitalization is something more connected with the guy in the garage. I think that hard technology, quantum, space will be the real game changers in the very next future.
Okay, you mentioned several times quantum technologies, keywords. Can you unveil the state of the art of quantum radar, if you have some news about this? Just something that you can say here to this audience.
Well, in Italy,
no top secret program.
No, I don't. Well, when I retired, I left all my top secret information in my last office.
Okay. One bring it home. Yeah.
Well, we made some, there are also a lot of scientific articles about quantum radar with Santan University. We made experiments. The actual gap is maybe the cost.
Just a matter of cost. So just
the fundamental core technology is quite running. It's at a pretty high TRL. So they have demonstrated the technology. But the 5, 6, I mean TRL. But things have to grow, and if you imagine with the crisis running from so many years that you have to pay a lot of money for a new technology which gives you actual performances close to the consolidated technology, then it is difficult to go ahead.
Okay. So there are good perspectives, but we have to wait and spend a lot of effort.
We have to see what's happening.
Okay. So thanks again. I believe that now it's time to thank you again, Sergio. I believe that the organization
ceremony. I would like to thank you very much for your help. Okay, we are almost at the end of this opening section. I have one message from the main organization that I have to remember you that on Wednesday evening there will be the gala dinner for the week. So there are still some space available. If you are interested, please get information to the information desk. Well, to conclude this session, well, first of all, I would like to thank the keynote speakers that give us a good overview of what we can expect in the future. And we really appreciate the support for this event. And of course, I would like to thank, special thanks to the authors that contribute with their work to the success, or I hope to the success of this event. The reviewers, their work behind all the activity to reviewing all the papers, selecting the papers that could be promoted for this online, for this in-person event. The TPC members that made a great job in a very short time, because as you realize, we were compressed by the previous conference, so they made a very good job in a very short time, so we're most active to compose the program of this event. I would like to thank the student team, the people that you cannot see, but they are behind all the activity. The young people with the blue shirt that are supporting in all the duties. Clearly, the organization teams, all the people. Again, and last but not least, I would like to thank all of you that you are attending this event, and I hope that you are making this EuMIC 2022 an extraordinary event. Thanks, and enjoy the conference.